Simply stated, Lockheed's SR-71 Blackbird is the fastest, highest flying jet airplane ever built. It can fly from sea to shining sea in only an hour. Now what, you may wonder, is such an exotic military airplane doing on wonderful world of flying? Although this exotic spy plane was retired from the Air Force in 1990, a trio of Blackbirds were given to NASA for high-speed, high-altitude research. In other words, they're among the latest additions to the general aviation fleet. Well, sort of. Only 32 of these sinister-looking machines were built. 12 were lost in tests and accidents. The Blackbird carries a crew of 2, a pilot and a reconnaissance systems officer who manages the astro-inertial navigation system, various sensors, and the electronic defensive systems, which I think can be used to guard against the FAA. The Blackbird is about the size of a DC-9. It has a maximum gross weight of 152,000 pounds, but more than half of that is fuel. This nose boom contains the pitot tube and static pressure sources, and this probe senses the direction of the airflow. In other words, it senses the side slip angle and the angle of attack. This blended forward wing is called a chine, and it gives the aircraft its cobra-like appearance. It extends from the nose back to the leading edge of the wing, running about 40% of the length of the aircraft. The chine acts like a fixed canard and contributes substantial lift and stability at high speed. The Blackbird is powered by a pair of Pratt & Whitney JT11D-20 engines, known in military circles as J58s. When operated in afterburner, each engine produces 32,500 pounds of thrust at sea level. This cover is here for a reason. The tip of this inlet spike is sharp, really sharp. Jet engines don't run very well on supersonic air, so you have to slow the air down before allowing it to enter the engine. And that's what this inlet spike does. As aircraft speed increases, the spike moves rearward. This prevents the engine from ingesting the supersonic shock wave. Otherwise, the engine will flame out, which at Mach 3 can create a violent yaw that is guaranteed to grab your attention. The Blackbird has a pair of biconvex delta wings that have a leading edge sweep of 53 degrees. The wings also serve as fuel tanks. In other words, the skin of these wings form the upper and lower walls of the wing tanks. But these aren't just regular wet wings. These wings get real wet. You see this seam in the leading edge of the wing? Well, the airplane is loaded with them. Fuel frequently will seep out of such joints and seams and form pools of fuel beneath parked Blackbirds. But during flight, at 3 times the speed of sound, the friction and compression of the air creates tremendous heat. This heat causes the structure to expand by almost 6 inches. This tightens the seams and prevents fuel from leaking in flight. At Mach 3, the temperature of the Blackbird's skin varies from 400 to 1200 degrees Fahrenheit. So one thing that SR-71 pilots don't have to worry about is structural icing. As a matter of fact, the skin gets so hot that nobody has to worry about cleaning bird poop from the airplane. The structure gets so hot that it acts like a self-cleaning oven and burns off the stuff during flight. Trouble is, decals get burned off too. This explains why 93% of the Blackbird's weight consists of titanium alloy. Aluminum gets too weak at such high temperatures. This also is why the airplane is painted with high emissivity paint. This black paint radiates heat almost 3 times as much as bare metal. The main gear tires are impregnated with aluminum powder. This helps them to reflect airframe heat during flight and keeps the rubber relatively cool. The tires, by the way, are inflated with nitrogen at a pressure of more than 400 pounds per square inch. Now that makes them as hard as rocks. The dual rudders are very much like vertical stabilators. They're canted 15 degrees inboard to help reduce undesirable rolling moments. Like other delta wing airplanes, the SR-71 does not have conventional ailerons and elevators. Instead, The Blackbird has 4 elevons on the trailing edge of the wing that combine pitch and roll functions. When the stick is moved to one side, the elevons act as ailerons. When the stick is moved fore and aft, they act as elevators. But when the stick is used to command a climbing right turn, for example, the elevons combine functions to produce the desired results. You would expect such a fast airplane to have smooth wings. The trouble is, when smooth surfaces get too hot, they curl like potato chips. This is why longitudinal corrugations, just like those on a trimotor Ford, are used to add strength to the upper wing panels and alleviate thermal expansion due to heat soaking. When viewing the aircraft from the side, it looks as though the pilot is sitting on the tip of a missile. But from this perspective, it looks as though you're sitting at the end of a sword that slices its way through the air.
The JP7 fuel used on this airplane has such a high flash point that normal ignition systems, well, just can't ignite it. Instead, a special chemical, triethylborane, or TEB, is injected into the fuel during the starting process, and this causes the fuel to ignite with a green flash. Remember, you don't want to use ordinary fuel in this airplane because the high temperature of the wings during flight might cause the fuel to ignite in the tanks. That would be bad news. Throttles up. Full afterburner. Nose wheel steering up to about 120 knots. 215 knots, rotate to 10 degrees. Lift off at 230 knots. Gear up in a hurry, can't exceed the geared limit speed of 300 knots. Jeez, what a kick. A takeoff in a Blackbird is made with a reduced fuel load. I know it sounds strange, but a fully loaded SR-71 can't climb out of ground effect at low speed in case of an engine failure on a hot day. So the first thing we have to do now is find a tanker for some mid-air refueling. Initial climb rate of the SR-71 is 10,000 feet per minute at an indicated airspeed of 400 knots. Not PSI is pegged out, but believe me, we're going up at almost 2 miles per minute. Just take a look at this altimeter. It takes only 3 minutes from brake release to reach the typical refueling altitude of 26,000 feet. Refueling usually is done at 350 knots, while the tanks are topped at 5,500 pounds per minute. The transition from subsonic to supersonic flight usually begins at about 35,000 feet and incorporates a maneuver called the dipsy-doodle. We're going to begin a descent of about 2,500 feet per minute at an indicated airspeed of 450 knots until we go through Mach 1. At Mach 1.25, we'll pull the nose up and resume our climb at 450 knots. Flying at 3 times the speed of sound at 80,000 feet, the SR-71 is in its own private sky. There's no other traffic up here, nor could there be. So there's no threat of a mid-air collision, except perhaps with a weather balloon. That can be a real hazard. By the time you see one on a collision course, it's probably too late to avoid. When the performance of the SR-71 was still top secret, pilots used to turn off their transponders above 60,000 feet so that controllers wouldn't know how high they were. High-speed aircraft don't turn very well, and this requires that a Blackbird pilot plan way, way ahead. In a 30-degree bank turn at Mach 3, for example, turn rate is only 0.3 of a degree per second. To turn around, a 180-degree turn takes almost 10 minutes, and the turn diameter would stretch, for example, from Dayton, Ohio, across Indiana, all the way to Chicago. Although the Blackbird doesn't turn very well, it sure does go in a straight line very, very well. While cruising at 1,800 knots, or almost 2,100 miles an hour, the DME ticks off a nautical mile every 2 seconds. And to go this fast, everything has to be in trim. A Blackbird pilot can look through this small periscope to make sure that the rudders are not offset and creating unnecessary drag. The SR-71 is pressurized, but not as much as a commercial jetliner. At 75,000 feet, for example, the 5 psi differential pressure results in a cabin altitude of 25,000 feet. Blackbird is not a fighter, and it doesn't fly like one. Subsonically, it feels like a big, heavy, lumbering airplane. Nor is it very maneuverable, and it can't take much of a load. At Mach 3, the airplane is limited to a load factor of only 1/10 of a G negative and only 1.5 Gs positive. The SR-71 has no flaps, spoilers or speed brakes or leading edge devices of any kind. Downwind at 250 knots. Check gear down and lock. Base leg at 230 knots. Turn final at 175. Nose up a little, up to about 12.5 degrees. Touchdown at 155 knots. No.
That for a ride. Well, I guess you realize by now that I wasn't really flying this airplane. I wasn't even in it for the ride. But boy, it sure would have been the ultimate $50 hamburger. Or should I say, $1 million hamburger. Those who really fly the Blackbird at high altitude need the protection of a spacesuit to provide life support in case of decompression or the need to eject. These $100,000 suits are the same ones used by astronauts during the early shuttle missions. Except for placing cooling fans next to the brakes, the ground crew knows to keep clear of the aircraft until it's had a chance to cool down, and this takes about a half an hour. After that, they get busy attending to the 650 items covered by 7 post-flight checklists. This is the SR-71 simulator that we use to videotape some of the instruments that you've just seen. You know, the Blackbird is a collection of superlatives and paradoxes. Some call it a guided missile with biological backup. How fast or how high does she really fly? I don't know. But informed sources say that Blackbird probably has a sprint speed of 2,350 miles an hour and could do Mach 3.5 at 100,000 feet. The Blackbird first flew in 1962 and was the world's fastest and highest flying jet airplane. Now, 30 years later, it still is. It is, unless those rumors are true about Lockheed building a Mach 6 aircraft codenamed Aurora. Could be. Only about 125 pilots have ever checked out in a Blackbird. It's a very exclusive club, and it's a club I'd like to join. So if you'll excuse me, I need some practice. is such an exotic military airplane doing on Wonderful World of Flying? Although this exotic spy plane was retired from the Air Force in 1990, a trio of Blackbirds were given to NASA for high-speed, high-altitude research. In other words, simply stated, Lockheed's SR-71 Blackbird is the fastest, highest-flying jet airplane ever built. It can fly from sea to shining sea in only an hour. Now, what, you may wonder, is they're among the latest additions to the general aviation fleet. Well, sort of. Only 32 of these sinister-looking machines were built. 12 were lost in tests and accidents. The Blackbird carries a crew of 2, a pilot and a 152,000 pounds, but more than half of that is fuel. This nose boom contains the pitot tube and static pressure sources, and this probe senses the direction of the airflow. In other words, it senses the side slip angle and the angle of attack. This blended reconnaissance systems officer, who manages the astro-inertial navigation system, various sensors, and the electronic defensive systems, which I think can be used to guard against the FAA. The Blackbird is about the size of a DC-9. It has a maximum gross weight of